Day 18 of Algebra 1. Today we're going to be talking about generating linear equations from word problems. So what does that mean? We're just going to be writing out the equation based on things that we read. Okay? So let's go ahead and get started. Okay. So first thing we want to identify is a couple of different items related to our equation. So when writing equations in a word form, we write them always in slope-intercept form. Y equals mx plus b, where m is my slope, b is my y-intercept. So each equation has two parts: a rate of change, my fancy word for slope, and a y-intercept, my b value. To identify the slope, we look for the following keywords: each, every, and per. To identify the y-intercept, which does not change, we look for the following keywords: initial amount, one-time fee, and service charge. Anything that's similar to those is going to be a y-intercept. All right, so let's go ahead and take a look at example number 1. Okay, so your cell phone company charges $20 service charge plus 10 cents per text message. Okay, so I saw the word service charge here, so I'm going to assume that this is my B or my y-intercept. And I saw the word per, so that's telling me that's probably an M. So I'm going to say my slope is 0.10, and my B value, my y-intercept, is 20, also written as 0, 20. So my equation should look like this, right? Okay, so now what they want us to do is they want us to graph it. Before I get into too much detail with that, I want you guys to be aware of something. Sometimes on my X and Y axis, people do not use 1, 2, 3, 4, 5, the regular counting numbers that we're used to. Sometimes they change it and they scale it in order to make our graph fit better. So, for example, if we were talking about the population of the world as far as humans, we wouldn't write 1, 2, 3, 4, right? Because those are really big numbers, so we need a really big graph. So we might make our y value over here really tall, and we'll skip in between each one of these. So always be aware. When I told you about counting boxes, the counting boxes only applies to the one-to-one. For these, we have to be very cognizant of it, okay? There is a way to count them, but what I would prefer you guys do is to write out the formula, okay? All right, so first thing, I see this equation. So I'm going to go ahead and I'm going to plug this into my calculator. I'm going to go to y equals 0.10x plus 20. I'm going to hit enter, and I'm going to hit second graph in order to get to my table. And I'm going to be looking for different values, okay? Now, over here they ask me 500, 1,000, 1,500, 2,000, 2,500. They're going by 500, okay? So I'm going to hit plus, right? And it's going to give me this, and I'm going to say 500. And look at that, starting at 0, 500, 1,000, 1,500, 2,000, 2,500. So let's go ahead and copy those down. So 500 is about 70, 1,000 is 120, 1,500 is 170, 2,000 is 220, 2,500 is 270. Okay, so now I want you guys to also notice something. Plus 50, plus 50, plus 50, plus 50. Okay, so for every 500 of x, right, we go 50 up in this direction. So for every 500 of x, we go 50 up in that direction. One more time. For every 50, I go in the y direction. Up here at the top, I go 500 in the x direction. If I simplified that, it is exactly the slope that I got before. I just have to be cognizant of it, okay? Now, the other way we could have done is plug it in the formula. I would have done 120 minus 70 divided by 1,000 minus 500. So 50 over 500, 50 over 500, 50 over 500. Same exact thing no matter where you do it, okay? Let me go ahead and clear this out. Okay, go ahead and get this bad boy graphed. So at 500, we have approximately 70. At 1,000, we have approximately 120. At 1,500, we have approximately 170. At 2,000, we have 220. And we really don't care what this is, right? All we care about is the math. All right? So we have all of those. I'm going to go ahead. I'm going to draw in my line the best I can. And my y-intercept should be somewhere around 20. Okay, there's my line. So it's fairly simple. All you have to do is just read it to make sure you understand it, okay? Let's try again. So first of all, I saw that they gave us a table, right? Let me go ahead and color code everything just so I'm not over here driving myself crazy trying to figure out what it all is. Remembering that my green is going to be my x's, my domain. My pink is my range, or y's. All right, so let's look at this. Jenny baked cupcakes and spent $4.50 on supplies. That sounds important. She sells them at a rate of $2. Okay, so rate tells me slope, so I already know my slope is 2. Spent $4.50. Is that ever going to change? No, that's a consistent, steady value. She always spent $4.50. That's all she spent. It's not going to change today, tomorrow, the next day, right? So my y-intercept is $4.50. Okay, so let's write the equation. Y equals 2x plus $4.50. All right. So now I can go ahead and plug in these values. For each one of these, I would plug in my x, right? So 2 times 0 plus 450, that'd be 450. And then 2 times 10 plus 450 equals 2450. 2 times 15 plus 450 equals 3450. 2 times 20 plus 450 equals 4450. Now, if you notice, 10, 10, right? This is the only outlier here because they didn't count by 5, because notice they were counting by 5s here. So I should be able to get the same exact slope. So what I'm going to say is, all right, I'm going to look at these. I'm going to say, well, what's the difference here? So I did plus 5, right? And then over here I did plus 10. So I'm going to divide y by x, 2. Same exact slope. I could have also have written it in, right? So I would say 4450, 3450, 20 minus 15, and I would have gotten the same exact answer. So let's go ahead and graph this bad boy. All right, 0 and 450, so somewhere around there. 10 and 2450, somewhere right there. 20 and 3450, somewhere around there. And oh, whoops, wrong one. Okay, so hold on. All right, so I didn't put 15 on the graph. Whoops, so this is why you pay attention. All right, here's for 15, and 20 is at 4450, which should be somewhere around there. Okay, so here is my line. Draw my arrows in case anybody's suspicious that line does not stop. And there is my graph. All right, let's take a look at another one. So again, they're telling me about range, domain. All right, let's look at the information. A book club has an annual budget of X dollars. Every year, 600 of the total budget is spent on snacks. One half of the remaining is spent on monthly activities for members. Write a function that can be used to find the amount of money on the monthly activities for members. Okay, so this is kind of one of those weird ones, and we have to really pay attention, okay? So there were 3 bits of important information. So the first one, they told us budget of X dollars. And they spend 600 on snacks every year. Half of the remaining is spent on monthly activities. Okay, so if I were to reduce that, it would look like this. So again, they have a budget of X, they spent 600, and half of everything that's left over, the top, is what they spend on monthly activities. And if I reduce that, remembering because it's 2 divides everybody, it goes into 1/2 in front of the X, and it slices my negative 600 into half. So let's go ahead and plug in each one of these. So this would be 1/2, 600, minus 300, 0. So if they had a budget of $600, they would have absolutely nothing left in order to spend on monthly activities. So 1/2 times 1,000 minus 300, they'd have $200. 1/2 times 1,500 minus 300, they would have $450. So now I just want to verify this information in my calculator. So I'm going to go back over here. I'm going to hit Y. I'm going to say clear. All right. So now I'm going to type in my equation, and I can type it in either way. If I want a fraction, I hit second Y equals. Oh, wait, no. Hold on. Sorry. Alpha Y equals. So I'm going to go back to my Y's. Alpha Y equals. And it's going to show this. I'm going to hit enter for the first one. I'm going to say 1/2 X minus 300. Enter. Second graph to get over to my table, and it looks like it is showing them to me using the X values I selected last time. But here they went 600, 1,000, 1,500, etc. Okay, but it looks like maybe I need to go by 100 to verify that. So I'm going to go ahead and put plus 100. My cursor has got to be selecting 0, otherwise it's going to start from this guy and go to 100, okay? So I'm going to hit enter, and here's my value. So I'm going to look for 600. Okay, that's 0 like we thought. Let's look for 1,000. That's 200 like we thought. 1,500 is 450 like we thought. All right, good job. 700 for 2,000. And then 2,500 is 950. All right. So that takes care of everything for day 18. What I want you guys to do is I want you to go ahead and take a few moments to focus on example 4 and 5. Remembering that if they say of the remaining, 1/3 of the remaining, 1/2 of the remaining, 1/4 of the remaining, you have to divide